Okay, so very last video is graphing inequalities. Okay, so if you think of the line, this one, y equals 1/2 x plus 1. Okay, let's say we want to graph it. Okay, so we know the y-intercept is 1, so we know the first point. And then I can find the next point using the slope, the rise over the run. So I go up 1 to the right 2. Okay, and then I can make a line right here. Okay, so when you have an equation like this with two variables, two factors that relate to each other, the line shows you all the possible answers, right? I can pick any point on this line, plug it into this equation right here, and both sides will be equal, right? That's what an equation is. Okay, just like what we did before, right? When we solved equations just with one variable, we got x equals a number, right? Now, when we have two variables with inequalities, you're going to get, instead of just a line as your answer, you're going to get a whole bunch of points that can fall in a certain area that are the right answer, right? So what does that mean? Let's pick a point above the line. Okay, so I'm going to pick a simple one. I'm going to pick this point 0, 3. Okay, so this doesn't lie in the line. So I already know if I try and plug it into the line, it's not going to equal, right? Because it's not on the line. But let's plug it in anyway and see what happens. So y is 3, x is 0, and you can pick any point. I mean, you could pick a point here, 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 here. I'm just picking a point above the line. Okay, so I'm just picking a simple one. 1/2 times 0 is 0. That's why I picked that one. So that leaves us with 1. Does 3 equal 1? No, but we already knew it wasn't going to work out, right? But how does 3 relate to 1? Is 3 greater or less than? It is greater than 1, right? Therefore, any point that lies above the equation, this shaded area up here, means that the left side, the y side, is going to be greater than the x side of the equation. So we can pick another point. We can test that out. So this is above, right? Let's test it. Is 5 greater than 1/2 x times 0 plus 1? Is 5 greater than 1? Yes, it is. It checks out, right? So that means any point that falls in the shaded area should fulfill this inequality, y is greater than 1/2 x plus 1. Okay, so you can see instead of just the answer on the line, right, now it's all the points in the shaded area. And this goes on for infinity, right? I mean, technically the shading goes forever and ever, and it continues this way and that way. But basically any point above the line, I can pick any one, I plug it into the inequality, it should work. So what do you think the area below the line stands for? If above it is greater, what's going to be less than? Below. I just gave it away. Less than, right? That means if we pick a point below the line, it should fulfill the inequality y is less than. Right, so we think of the line as the equal, the above is the greater, and the below is the less than. So let's just test a point. The origin just so happens to lie below the line, so let's test the origin. 0. That's just 0. Is 0 less than 1? Yes, it is. That checks out. Right, and again, you can pick any point. Maybe this is 4, 0. So 0 less than 1/2 times 4 is 0 less than 3. Yes, it is. Right, so this whole shaded area below is the less than area. so let's just do, let's just graph some inequalities. Okay, so we've got y is greater than or equal to 1/3 x plus 2. So again, just like graphing a line, you're using, this is in slope-intercept form. So here we've got 2, and then to find the next point, I go up 1, to the right 3. Okay, and so this inequality, it can equal the line, so I'm going to make a solid line. And I'll talk about what happens when it doesn't equal later. Right, so because it's y is greater than or equal to. So the line is solid, greater than, what area of is it above or below the line that's going to make y greater than 1/3 x plus 2? Greater than means you shade above the line. Okay? I hope I have enough room. Okay, so this time, 1, 2, 3, 4, 5. My first point, that's my intercept, right? 5. And then my slope, remember, it's a whole number, but so that means it's over 1. Right, so I go down 2, to the right 1. But something to notice here, it's y is less than. It cannot be equal to. So that means our line is a boundary. So remember when we just did basic inequalities with just one variable, with x? We did an open circle, right? So this is kind of the same concept, except we can't do a circle. So we do a dashed line to represent this is the boundary. It cannot equal the line, but the line is the boundary. And then we want to shade less than. What is less than? Above or below? Less than is below, right? So what's underneath the line? Right here. Okay. So this shaded area represents all the possible points. So I can pick any point in the shaded area that I want, plug it into the inequality, and it should work. I should get whatever is I have for y is less than -2 times whatever I plug in for x plus 5. Right? So I can pick any point in the shaded area. So an equation, right, gives us just a line, and the line's all the right answers. And inequality, you have a shaded area, so you have way more answers compared to a line, right? Something important to remember too is you're gonna have to like write it. Oops, not equals. If it's not in slope intercept form, you're gonna want to rewrite it, because the whole rules for shading below and above don't work out when it's in this form. You can just pick points and test it if you want, but I find it's just easier to convert it, so. Okay, so I'm just solving for y less than right, so my y-intercept is 6, down 3, 1, 2, 3, to the right 4. Is this a solid or a dashed line? It can't be equal to the line, right? So the line is just going to be a boundary. So I'll make it dashed. And then less than, I shade below, right? So all the right answers are this shaded area. If there was, if it's less than or equal to, then I would make my line solid, right? because it can equal the line or it can be less than. So it's going to be the line and the shaded area is your right answer. And that's how you graph. So it's just like, it's still using slope-intercept form. You still use the same concepts. You're just going to add shading and dashed lines, right? So if you have this or this, remember you have a dashed line, less than or greater than. If you have less than or equal to, oops, no, actually, oops, Jesus, okay. Less than or equal to or greater than or equal to, it's a solid line. Okay, that's just going over some of the basic rules. Though basically it's the only thing that makes it different from graphing a line. If you have less than or equal to, you shade below the line, right? If it's greater than or equal to, you shade above the line. But otherwise, just like graphing an equation, you just have these extra rules to remember. Okay, it's always how it goes with inequalities. It's so close to being an equation, just slightly different. And yeah, that's the topic of graphing. I just know that's like a ton of stuff. That's why I made the last 2 weeks a little simpler. Maybe I should have made this 2 weeks. I'm not sure, but let me know if I should make it 2 weeks because I'll change it for next quarter. But yeah, here, this is graphing.